Welcome to Lecture 3 for Newton's laws, and today we're going to look at three different equations. The first one is to find the frictional force, that's F sub F equals mu. Now this is micro, the Greek letter micro. And this is your normal force, which is the weight, as you remember from your free body diagrams. You see force is in newtons. Now the coefficient of friction has no units. Another one is F equals Kx. Well, F is force, K is your spring constant, so there's a key word for this one, and a spring stretch, or we could say a compression here, which is, now this should be in meters, little typing problem there. That's our lowercase m, not a big M. Okay, you can see the force is in newtons, the spring constant is newtons per meter. Here's one. Now this one, you're going in a circular motion, so let's put a circle. So you think of, in a circle, you have a force and a mass, a velocity, and the radius, or this could be the length of the rope. Now this will be in a horizontal direction because in the next one you'll see we'll use that a little different. The coefficient of friction with the frictional force, as you remember, your friction could be static or kinetic. And you're probably thinking, I need two equations. No, use this one. It works. Remember, friction is friction, and the static or kinetic is just to denote what's happening. Okay, so let's kind of look. It says, what is the coefficient of static friction if it takes a 40 Newton force to start a 5 kilogram object moving? So here's our force. So we must, okay, you got static. So just to overcome it, it's just like when you're jumping, you just have to overcome its weight. So to overcome an object moving, you have to overcome its weight, and that would be the frictional force since we're not accelerating. And here's our mass. So this is F sub F, not F, big F, small f. This is F sub F equals. Now you're probably thinking, how do I write this? If you're not adept at writing this, if you haven't written it a couple of thousand times, like your teacher did, the easiest way to do it is draw a U like this, and on the front side just go straight down. You don't have to embellish it. It almost looks like a backwards Y. Be very careful. Don't put a little loop in there because it looks like an N, or some people think an N is mute. No, ask the Greeks. And so there's this N. Okay, so you can see we need 40 newtons to start this. Okay, we're looking for the U. I've written this thousands of times, so it's easy, but I'm showing you how I would do it if I was just starting out. Makes it easy. Now you're thinking, oh, normal force. Ooh. Remember, that's the weight, and to get weight is the mass times 10. Remember, normal force and weight are the same. Let's make that in a little bit clearer. There we go. And you're, okay. And you're probably thinking, what are the units for the coefficient of friction? The coefficient of friction, if you do your division here, the newtons cancel there, so there's no units. Do not put units for the coefficient of friction. Okay, next one. Oh, a spring. It has a spring constant, so this will clue you in to which equation. So if you see spring constant, you're going to have to look for something with a K in there, and this is the only one for this lecture, so F is equal to Kx. Says I need to stretch it. Remember, I can either have stretch or compression. So the force is equal to K, which is 400 times 0.5, okay? And the force, as we know, will be in newtons. And here's an example for the third one. Okay, I want force. I've got a 75 kilogram object that's traveling in a circle. Now remember, these will be horizontal circles, and the next one we'll do vertical circles. So F, that's an F. Don't want to make it look cross between, there's an F, equals mv squared over r. So F, okay, there's 75, 30, and don't forget the little square, and 25 meters. So the F will be in newtons. So let's see, there's one down here using the same equation, but we're looking for something else. So F, so you can see there's a key word, radius, NV squared. Don't forget to square in your equation, and make your R's a little bit nice and clear. I probably didn't give you much room to write. Now, if you do a slash, be careful when you do that. That's the reason why I like to do the straight lines, and I make sure I have plenty of room. Whoop, messed up because let's try this, because I forgot to put in the 70,000. We'll put that 0 there. The 1900 kilograms, and there's the V. There's your square, so don't forget that. And 450, and V, as we know, is in meters per second. I'm just kind of skipping around. Here's one. How much force does it take to keep a 45 kilogram object moving? Now remember, this one was static friction, and I gave you kinetic friction. You're thinking, oh my goodness, another equation. No, use the same equation. Remember, friction is just a mode. It can be either static or kinetic. Remember, that's F sub F. That's the way I do mine. Over N. Now, the thing is, okay, I want this. And 0.15. Now remember, this is normal force, so you have to change your kilograms to weight to multiply by 10, or if your teacher tells you 9.8. And there's normal force. And we're going to quickly do one more. Okay, spring stretches this much. What is the spring constant? So there's this. If you see spring constant, it's pretty good what equation you're going to use in this section. So if I say 250 equals, and I want K, 0.055, so K is going to be in newtons per meter. Now this would an offshoot of a classic experiment you might do in your physics class, or maybe a physical science class, where you either stretch or compress a spring by adding a mass. So in other words, to get the spring constant, you change your mass to a weight. In other words, multiply by 10, and you just pop it into that equation, as we would say. Enjoy doing the ones I didn't do for you. And remember, if you do have any questions, don't hesitate to contact me.